Hello, algebra students. We are on day 2 of chapter 7, solving linear systems. Yesterday we talked a little bit about the fact that we have 3 different methods that we can solve systems of equations by. And yesterday we did the graphing both by hand and by the graphing calculator. And so today we're going to go on to the second method that we talked about, which is substitution. So let's just go through some steps on how to solve a system of equations using the substitution method. First, we want to solve one of the equations for one of its variables, and it doesn't really matter if you solve it for x or y. In step 2, then, once you've done that, substitute that expression from step 1 that you just did into the other equation and then solve for the other variable. Once you've done that, you will have your solution. Then you substitute that value from step 2 into the revised equation from step 1 and solve. And then once you have your ordered pairing, we always write them in ordered pairs, our solutions, then you can check that solution in each of the original equations to make sure that it is the correct solution. We always know that we want to use the substitution method to solve a linear system of equations when at least one of our equations is solved for one of the variables already. So if we look at our 2 equations, the first one is not solved for either one of the variables, but the second equation, y equals x minus 1, is solved for y because y is by itself. It's isolated on one side of the equal sign, which is what we're looking for. So anytime we have a system of equations where at least one of the equations is solved for either x or y, it doesn't really matter, then we know we want to use the substitution method to solve that system. So in just regular math that we've done for years and years, you know that we can write an equation like 2 plus 3 equals 5. Now, you know that this is one way of saying 5. Of course, that's another way of saying 5. And they mean the same thing. 2 plus 3 means 5. So if I wanted to, in some equation that I was working on, if I had 5, I could substitute 2 plus 3 in that equation if I wanted to, because they mean the same thing. We can actually use that thought for y equals x plus 1. Y is x minus 1. Y is x minus 1 in this particular equation. They mean the same thing. That's what equals means, as we all know. So wherever I see y in this equation, I can just substitute x minus 1 because this says that they mean the same thing. So I'm going to rewrite this equation, the top equation, using x minus 1 in place of y. So let's rewrite that as x minus 5. Now I need my parentheses, as always, and here's my x minus 1 going in for this y right here, because I can, because they mean the same thing. And so that's going to equal a negative 15. So now we are going to be able to solve for x because we have the same variable in this equation. There's no way we could figure out what either x or y were in that format. So we need to have the same variable going on at the same time so that we can solve for that variable. So the first thing we have to do, of course, is to distribute that negative 5 to both the x and the negative 1. So we have x minus 5x plus 5 equals negative 15. So now let's do a little combining like terms here, and we have x minus 5x is negative 4x plus 5 equals negative 15. I'm always trying to isolate that variable. That's my goal in every solving of an equation. So let's get our constant over on the right side by subtracting 5 from both sides, and we have negative 4x equals negative 20. X is still not by itself, so we have to divide both sides by negative 4. And x equals 5. So we have the value of our solution. We have the x value of our solution. I usually go up someplace and write that in my parentheses so I don't forget what it is. So now that we know what x is, we can substitute this value for x, which is y, which is 5. These two mean the same thing. So now we can go back to either one of the original equations. It doesn't matter. I always try to find the one that looks easier or has less negatives, or where one of the variables is by itself on one side of the equal sign. So I'm going to choose the second equation. I certainly can choose the first if I want to, but I'm just going to choose the second one because I think that'll be easier to solve. So I'm going to come up here and substitute 5 in for x in this equation. So y equals 5 minus 1. Do the math, and we have y equals 4. So the y value of our solution is 4. We always want to write our solutions as an ordered pair, because don't forget from yesterday's lesson when we learned that the two lines intersect, and that point of intersection is an ordered pair on the graph, and that is the solution. So the solution to this system of equations is the ordered pair 5, 4. All right, so this next system of equations that we want to solve, if you look at both of the equations, this one is not solved for one of the variables, but this one is. This time it's solved for x, because x is by itself on that side of the equal sign. So in this case, x and y plus 3 mean the same thing. The equal sign tells us that. So we can substitute y plus 3 in right here where we see x in the other equation. So let's do that now. So we have 2, use your parentheses, times y plus 3, that's really x, same thing, and then bring down that plus y equals 3. So to solve that, now we have the same variable in this equation, so it's going to be easy to solve for that variable. So let's distribute, and we have 2y plus 6 plus y equals 3. Let's combine some like terms, and we have 2y plus y is 3y plus 6 equals 3. Let's get our constants on the other side by subtracting 6 from both sides, and we have 3y equals negative 3. Divide both sides by 3, and we have y equals negative 1. So I'm going to go up here and make my ordered pair form so that I don't forget that my y value in that solution is negative 1. So now that I know that, I can go back to one of the original equations. It doesn't really matter which one. But again, I'm going to choose this second one because I know what y is, and it'll be easy for me to find x. So I'm going to use that equation, x equals, and I know y is negative 1 plus 3 from the original equation. So x equals 2. So I know that my x value of my solution is 2. So my solution to this system of equations is 2, negative 1. And you know from yesterday that if we graphed both of these lines, the point of intersection where they cross would be at 2, negative 1. So that's how we solve a system of equations by using the substitution method. Next lesson, we're going to be working on our third method of solving systems of equations, and that is by linear combinations, or we also call it by elimination. And until then, we'll be working on our problems, our practice problems for substitution. And until next time, see ya.